The Cybertruck is unlike anything that has ever been mass-produced in the history of the automotive industry. The story of how it went from a wild concept on a sketch pad to an actual vehicle rolling off the production line at Giga Texas is one of the most fascinating manufacturing stories in recent memory. Elon Musk first floated the idea of an electric pickup truck publicly back in 2016. What followed was nearly 8 years of promises, delays, shattered glass. Genuine engineering breakthroughs that nobody in the traditional auto industry thought were actually possible. The whole project was initially codenamed Project Blade Runner. That tells you everything you need to know about the design direction Musk had in mind from the beginning. He's talked openly about drawing inspiration from the Lotus Esprit driven by James Bond in The Spy Who Loved Me. He actually owns one of the original cars from that film, as well as the F-117 Nighthawk stealth aircraft. Blade Runner. Basically any piece of science fiction that ever imagined what a truck might look like in the distant future. He even has a phrase for the overall aesthetic, the wedge design language of the 1970s, that back then was considered the pinnacle of futuristic automotive thinking. The Cybertruck is essentially a modern interpretation of that era taken to its absolute extreme. The public reveal happened in November 2019. If you watched it live, you probably remember the moment that made the whole thing go viral. Tesla's chief designer Franz von Holzhausen threw a metal ball directly at the supposedly armored glass windows of the prototype. They shattered immediately on stage. Musk's reaction was pretty much unfiltered. The clip spread everywhere. Overnight, the Cybertruck became either the most exciting or most ridiculous vehicle on the road, depending on who you asked. At that same event, Musk announced production would begin in late 2021 with a starting price of around $39,900. Neither of those things happened. What actually happened was a series of delays driven by the COVID-19 pandemic, supply chain problems. The sheer complexity of building something that had never been manufactured at scale before. The timeline pushed to 2022, then to late 2023. The base price climbed to roughly $60,990 by the time real deliveries began. To his credit, Musk never pretended the challenge was small. He acknowledged publicly that the Cybertruck design was genuinely difficult to produce and that manufacturing stainless steel at automotive volume was a problem nobody had fully solved. The delivery event finally happened on November 30th, 2023, at Giga Texas. This time, von Holzhausen threw a baseball at the armored glass, which held just fine. So how do you actually build one of these things? It starts with the material itself, which is fundamentally different from anything used in conventional car manufacturing. The Cybertruck uses a custom stainless steel alloy that Tesla internally refers to as hard freaking stainless, or HFS. It was engineered specifically for this vehicle to be hard, highly corrosion resistant, still ductile enough to be shaped during manufacturing without cracking. Tesla receives this material not as flat sheets, but on massive rolls that then have to be uncoiled and flattened before any other process can begin. Here's where it gets interesting. You cannot stamp stainless steel the way you stamp aluminum or conventional steel for a normal car body. The material is too hard and too unforgiving. Any surface imperfection will be permanently visible because there's no paint layer to hide it. Tesla's VP of Vehicle Engineering, Lars Moravi, explained that the company had to essentially invent a new manufacturing process to solve this problem. They call it air bending. Instead of dies physically pressing against the surface of the material, high air pressure shapes the steel along precise lines without actually touching the face of the panel. This is critical because every scratch, every tool mark, every slight deviation in surface finish would show up permanently on a finished Cybertruck sitting in someone's driveway. The panels are laser cut with what Tesla engineers described as micron-level precision. One of the engineers involved said the laser cutting machine was the first of its kind, developed in a special collaboration between Tesla and German industrial equipment manufacturer Schuler. The laser blanking line handles the uncoiling, flattening, and cutting all in one continuous process. Working the material too aggressively at the flattening stage can harden the steel. That means it becomes brittle and will fail later in the bending process. So the whole operation requires a level of finesse that takes time to dial in. Mike Ramsey, VP Team Manager for Automotive, put it plainly: when you cut stainless steel, all the mistakes show up. On a flat plane like the Cybertruck's body panels, there's nowhere to hide. Once the panels are cut and bent into shape, Robots take over positioning and welding with a level of precision driven by CNC control and computer vision systems measuring dimensions in real time. Because the exoskeleton is structural, the stainless steel door panels alone absorb 75% of side impact crash load. Alignment and fit are not just cosmetic concerns, they are safety critical. Musk reportedly set what he called Lego-like build quality standards for the team, meaning every panel gap, every flush surface had to be nearly perfect before he would sign off on ramping up production volume. The consistent brushed finish on all exterior panels is actually the final cosmetic step in the production process, since there is no paint shop involved for the body exterior. Underneath all of that stainless steel, the Cybertruck shares more DNA with the Model Y than you might expect. That makes sense given that both vehicles are built at the same Giga Texas facility. The underbody starts with the structural 4680 battery pack. That functions as the central chassis section of the vehicle, holding all of the battery cells along with integrated cooling and electrical architecture. The 4680 cells used in the Cybertruck actually yield about 10% more energy than the Model Y's 4680 cells produced on the same campus. By June 2024, Tesla had produced over 50 million 4680 cells at Giga Texas, with daily production rates climbing from around 85,000 cells per day in mid-2023 to over 126,000 cells per day. Front and rear gigacastings bolt onto that structural battery pack to create the complete underbody. The electric motors are integrated into those castings, with one in the front and one in the rear, each connected through a gearbox to the drive axles. The suspension ties into the castings. The whole rolling structure comes together much like the skateboard architecture Tesla uses across the rest of their lineup. The difference with the Cybertruck is scale. Everything is bigger, heavier, built to the kind of durability standard you'd expect from a vehicle positioned as a genuine work truck. The marriage of the upper body to the lower assembly is where the two parallel production streams come together. The stainless steel exoskeleton, fully shaped and brushed, drops down onto the powertrain and battery assembly and is bolted together around the perimeter. From there, the interior comes together with seats, trim, electronics. Tesla's characteristic minimal dashboard centered around a large touchscreen. The windshield and glass elements are fitted and sealed. The doors are aligned and tested. The finished vehicle moves through final quality control before it's cleared for delivery. What makes the quality control stage particularly important for the Cybertruck is that there is no cosmetic fallback. On a painted vehicle, minor surface variations can sometimes be addressed in the finishing process. On an unpainted stainless truck, if something is wrong with a panel, that panel has to be replaced. Tesla's approach has been to run the production line deliberately slowly in the early phase, prioritizing quality over volume while the team refines every step of the process. Musk has said he wants to reach 250,000 Cybertrucks per year by 2025. That is an enormous scaling challenge given where production currently sits. The lessons being transferred from the much more mature Model Y line next door at Giga Texas are playing a direct role in accelerating that ramp. Giga Texas itself is worth understanding as the backdrop for all of this. It's the second largest building in the United States by volume, behind only the Boeing Everett factory. It serves simultaneously as the production home for the Model Y sold across the eastern U.S. The Cybertruck, Tesla's next-generation vehicle currently in development. The company's corporate headquarters. Tesla has been running a program at this facility where vehicles, including Cybertrucks, now drive themselves autonomously from the production line to the outbound logistics area without any human behind the wheel. In July 2025, Giga Texas went through a planned production halt officially described as maintenance and upgrades. But the broader purpose appeared to be addressing Cybertruck production inefficiencies, preparing the line for an updated Model Y, optimizing overall output heading into the back half of the year. These kinds of retooling shutdowns are a normal part of scaling a new vehicle. Tesla has used them before at other factories to come out the other side, running at higher volume and better quality. The Cybertruck's manufacturing story is really the story of a company betting that it could invent solutions to problems that didn't have solutions yet. Tesla brought in aerospace manufacturing techniques, partnered with specialized industrial equipment makers in Europe, built new machines from scratch when existing ones didn't exist, ran their production line at a loss of speed in the short term to protect quality in the long term. Whether you find the vehicle's design compelling or not, The engineering required to actually build it in volume is genuinely without precedent in the automotive world. And now that the production process has been refined and the line is steadily ramping, the bet is starting to pay off.